Okay, today's discussion is going to be about some of the simple machines that you may have encountered or possibly you may have studied in other classes like physics possibly. Basically, I'm just going to show some of the terms and symbols that I use when you're making sketches of simple machines and when you're trying to identify the simple machine parts. So let's walk through real quickly what these symbols are and how you should represent the sketches for any problems we'll have with simple machines. Well, basically, we'll start out with the inclined plane, and I just wanted to identify the parts and get a feel for what you're trying to solve. You have a weight that is on a ramp, so to speak, that goes up on an incline. That incline is identified by this Greek symbol called theta, and that will be a possible indication as to how you can solve the problem. That force that you're going to use to drag that weight up the ramp is called pull, or abbreviated P. Now the weight gives a vertical distance straight down. We have the height also of the ramp from the level line. We have a length of the ramp in addition to that. Those are very important key points to solving inclined plane problems. The next is pulley problems. Basically, we have two wheels. They're called sheaves. And between them is a flexible belt. And that moves in a direction I'm showing the arrow. Now, the driver, this would be the pulley on which the motor may be attached or where the input comes for making the pulleys move. And that driver is rotating at a speed which is identified as RPM, or revolutions per minute. As this one rotates, the belt moves, the other pulley moves. That's called the driven. Most problems are such that the smaller pulley is the driver and the larger pulley is the driven. And if you know what the diameter of the driver is and the speed and the diameter and the speed of the driven, well, then you ought to be able to solve just about any problem. Now going back to levers, this is also, not a lever, excuse me, inclined plane. This is also an inclined plane. It's a wedge, and you can see if we force down using P, then we can put load on the sides. Say, for example, splitting a log. That Q represents force, and it's how many pounds of force that we can exert on the sides of the wedge or the log or whatever it is that we're trying to force this into. This particular pulley situation is called a windlass. And the windlass has the two sheaths on one center so that they act on the same center, but the weight is mounted on a smaller pulley, and the force of the pull is on the larger pulley. These R's represent the radius. The capital R is the larger pulley, and small r is the small pulley. And again, if you know three of these variables, then you can solve the fourth. The third is the chain drive, very similar to a pulley drive. I just wanted to bring it up because I wanted to make sure that you understand the terminology. Again, a driver and a driven. And this time, instead of having a flexible belt, we have a metal belt chain. And the important thing about that is they have links. And that's important in solving some of these problems. And each one of these chains, the chain is mounted on a sprocket, two different sprockets. And what's also important about that is the number of teeth that you need for solving those problems. Now the spur gear, in this case we're putting the driver here, which is called the pinion, and mounting it directly to the driven gear, turning it, and I put the arrows to show the indication of the movement of the teeth together. And we also have to encounter the number of teeth on this spur gear as well as on this spur gear And then as these gears move, there's a point at which these gears contact each other, and that point is called the pitch line. That's where the two gears actually come together and interact. Those are factors that you'll also have to consider. Now, as far as the screw drive is concerned, screws can be used for a number of functions other than just fasteners, and in this case here, this is used to transfer power or load. And my diagram's showing some basic elements of the screw drive. For one, the screw thread itself has a factor called P, which is called the pitch of the thread. In other words, it's the distance between each thread. So that pitch can be determined by using this little formula here, the inverse, or 1 over the number of threads per inch, and that'll tell you what the pitch is. Now, what's important about this also is this R. This is a radius of the handle. There's a handle on this stand, and as you turn the handle, the screw thread moves. And so to determine how much force we need on the handle, we're actually looking for F, and the F is what the pull would be in order for you to move that handle and eventually move the screw up or down. So those are important factors for screw drives. And finally, the lever. There are 3 cases of levers here. This is probably the most common one that we'll encounter. And it's a bar across a point called the fulcrum. The weight is on one side, the force is on the other. And what's important about this is to gain a mechanical advantage by positioning the fulcrum at a specific distance from the weight and from the force. And you're going to get a mechanical advantage there. So capital L is from the fulcrum to the force, and small l is from the fulcrum to the load. And as we pull on that force, we'll lift the weight on the other side. Now there are a couple other cases or situations that you could use. You could put the fulcrum on the left side with the weight in the middle and the force on the right. This might be a situation where you would encounter with a wheelbarrow. And then you can put, in case 3, you can put the fulcrum on the left, and this kind of the force in the middle and the weight on the end. This might be an example of, for instance, a canoe paddle. If you're going to canoe, you're going to using the force here in the middle, and you're going to move the paddle through the water. So there's the basic machines, simple machines. In the class notes, you'll find the formulas for each of these. You'll also get some other background information, and you should be well prepared now to solve any problems that you're given in this particular section. So thank you very much, and let's move on. Thank you.